Use the definition of the derivative to find f prime of x. The definition of the derivative is written down below, which is the limit of f of x plus h minus f of x over h as h approaches 0. Consider the parabola y equals 4x minus x to the second. Use the definition of the derivative to find f prime of x. Find the slope of the tangent line to the parabola at the point 1, 3. Find an equation of the tangent line and graph the parabola and the tangent line. Part A. Use the definition of the derivative to find f prime of x. Now the definition is the following. F prime at x equals limit as h approaches 0 of f of x plus h minus f of x all over h equals limit as h approaches 0 of, we have h down below, and we have a subtract. F of x, what comes after the subtract, is clearly 4x minus x to the second. And now we need to plug in x plus h as an expression into the function 4x minus x to the second, which gives us 4 times x plus h minus x plus h to the second equals limit as h approaches 0 of 4 times x plus h, which is 4x plus 4h. X plus h to the second will give me 3 terms. That's x to the second plus 2xh plus h to the second. Let's do that and distribute the minus sign at the same time. So we have minus x to the second minus 2xh minus h to the second. Now the last part, we need to distribute the minus sign to 4x minus x to the second, and that will give me minus 4x plus x to the second. Now let's see what we could cancel and simplify. We have x to the second cancels right here. We have also 4x cancels. Let's write that without those terms that we have cancelled. Equal limit as h approaches 0 of 4h minus 2xh minus h to the second. Notice that every single term has an h, so let's factor out 1h. Limit as h approaches 0 of h outside as a common factor, 4 minus 2x minus h all over h. Clearly we could cancel this h right here, and that will give me the desired look that we could substitute h equals 0. Limit h approaches 0 of 4 minus 2x minus h. Well, clearly as h approaches 0, we have this goes to 0, and we end up with equal 4 minus 2x. And that's the derivative in general, or the slopes everywhere, that belongs to the parabola. 4 minus 2x, using the definition of the derivative formula. So for part A, we had f prime of x equals 4 minus 2x. For part B, find the slope of the tangent line to the parabola at the point 1, 3. That will be f prime of x at x equals 1. So f prime at 1, which equals 4 minus 2 times 1, 4 minus 2, and that is 2. So we have the slope, we have the derivative, and we need to move on to part C to find the equation and then graph it. So far we have f prime of x equals 4 minus 2x, f prime at 1 equals 2. To find the equation, we could use the point slope formula. Y minus y1 equals m times x minus x1, and that will give me y minus y1 is 3, and slope is 2 from part B, times x minus x1, which is 1. That should do it. But if you want to write it in slope-intercept form, we could do the following. We could write y minus 3 equals 2 times x minus 2 times 1, which is minus 2. Then add 3 to both sides. And we end up with y equal 2x plus 1. That is slope-intercept form, and the one on the left is the point slope form. To support that graphically, we have the following. We have f prime equals 4 minus 2x. The slope at that point is 2. The equation is y equal 2x plus 1. And to graph it roughly, we have 4x minus x to the second. If we set it equal to 0, we could factor x out. We have 4 minus x. Clearly that we have x1 equals 4 and x2 equals 0. So it goes through 0 and 4. And since we could look at it as y equal minus x to the second plus 4x, where a equals -1, which is less than 0, so the graph opens down. The vertex will be at 2 when x equals 2 halfway. So if plug in 4 times 2 minus 2 to the second, that's 8 minus 4, which is 4. So 2 will take me up to 4, and roughly we have the graph that goes through these 3 points going down. The equation of the tangent line is 2x plus 1. So we have a y-intercept of 1 and a slope of 2. It's going to go up 2 over 1. And the point was 1, 3. And this is the point 1, 3, which is right here. The graph goes through this point, and 0. And of course, through this point. The tangent line is going to be connecting this point and this point. Again, we could move on 2 up and 1 right, and we could go keeping the same slope, and that should do it. A cleaner look of the graph is right here. And that is it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.